Welcome back, everyone. I am Hari, and joining me today is the wonderfully insightful Kimi. We have an incredibly fascinating topic lined up for you.
Thank you for the warm introduction, Hari. I am absolutely thrilled to be here. Today, we are exploring a condition that affects millions of people globally, but is still surrounded by a surprising amount of confusion. We are talking about celiac disease.
Or celiac disease, depending on where you live. The Commonwealth prefers the spelling with an OE, while North America drops the O. But regardless of how you spell it, this is a serious chronic autoimmune disorder that primarily targets the small intestine.
Exactly. The trigger for this autoimmune response is gluten, which is a protein found in wheat, barley, and rye. When someone with a genetic predisposition to this condition consumes gluten, their immune system essentially goes rogue. It causes severe inflammation that damages the lining of the small intestine, leading to malabsorption.
And the symptoms are incredibly vast. The classic form, which is usually diagnosed in early childhood, features malabsorption symptoms like weight loss, chronic diarrhea, and stunted growth. But there is also a non-classic form that we see more often in adults.
That is right. Non-classic celiac disease presents with more vague abdominal symptoms and extra-intestinal manifestations. Because it affects nutrient absorption, people can develop bone disease, severe anemia, chronic fatigue, and even brain fog. It's a truly systemic disorder, meaning it can impact the entire body.
It can even affect the liver, causing what is known as celiac hepatitis, or lead to reproductive disorders like delayed puberty and infertility. Because the symptoms are so diverse, it often takes more than a decade for someone to receive a proper diagnosis. People just get accustomed to living in a chronically compromised state.
Which is absolutely tragic. And speaking of history, the timeline of how we came to understand this disease is wild. The term celiac actually comes from the ancient Greek word koiliakos, meaning abdominal.
Yes, the very first description is credited to Aretaeus of Cappadocia back in the 2nd century. He described a debilitating malabsorptive syndrome with chronic diarrhea. But his theory on the cause was a little off. He blamed it on a lack of heat in the stomach, or sometimes even drinking a copious draught of cold water.
It was not until 1887 that a British pediatrician named Samuel G. gave the first modern-day description. He perceptively noted that if the patient could be cured at all, it must be by means of diet, but his dietary recommendations were quite bizarre.
To say the least, he forbade fruits and vegetables, which are perfectly safe, and recommended raw meat and thin slices of toasted bread, which is literally the worst thing you could give them. He even highlighted a case where a child was fed a quart of the best Dutch mussels daily.
A quart of mussels every day? Surprisingly, in 1924, an American pediatrician named Sidney V. Haas reported positive effects using a banana diet. That trend actually stayed in vogue until the real culprit was discovered during a very dark time in history.
That is perhaps the most astonishing fact. The link to wheat was made in the 1940s by a Dutch pediatrician named Willem Karel Dick. During the horrific Dutch famine of 1944 and 1945, flour was incredibly scarce. Dick noticed that the mortality rate among children with celiac disease dropped from over 35% to essentially zero during the bread shortage.
And when the conflict ended and wheat became available again, the mortality rate soared right back up. By 1952, a team in England confirmed that the gluten component of wheat was the exact trigger.
It really highlights how much environmental factors play a role alongside genetics. Speaking of genetics, let us look at the underlying mechanism. Almost all people with celiac disease carry either HLA-DQ2 or HLA-DQ8 gene variant.
But here's the catch. About 40% of the general population also carries these genes and never develops the disease. So having the gene is necessary, but not sufficient. There are other environmental modifiers at play, like infections, the gut microbiome, and even the timing of gluten introduction in infancy.
And here's one of those lesser-known facts that just blew my mind. You would assume an evolutionary trait that causes severe health problems would eventually die out, but the HLA-DQ2 gene is actually most common in areas where gluten-rich foods have been eaten for thousands of years.
Right, and scientists believe it might have been genetically favored in the past because it actually helps protect against tooth decay. It's an amazing biological trade-off.
Let us talk about what actually happens in the gut. The proteins responsible are prolamines, like gliadin in wheat, hordein in barley, and secalin in rye. There's an enzyme in our bodies called tissue transglutaminase, which modifies these gluten peptides, making them highly stimulating to the immune system.
This leads to a T-cell-mediated inflammatory process that destroys the villi. That destruction is known as villus atrophy, which completely impairs the bowel's ability to absorb nutrients. That's why diagnosis is so critical.
Diagnosis usually starts with blood tests, specifically looking for tissue transglutaminase 2 immunoglobulin A, or TTG-IgA for short. It is highly sensitive and specific. However, if someone has an IgA deficiency, which is common in celiac disease, doctors have to use IgG-based tests instead.
And if the blood tests suggest celiac disease, an upper endoscopy is performed to take biopsies of the duodenum. Pathologists look for specific markers using the Marsh-Oberhuber classification, such as intraepithelial lymphocytosis and villus atrophy.
But here is the most frustrating part of the diagnostic process. To get an accurate result on both the blood test and the biopsy, the patient must actively be consuming gluten. If they have already cut it out, they have to undergo a gluten challenge, which some sources previously suggested meant eating over 10 grams of gluten a day for months, though current medical guidelines typically recommend just 3 to 10 grams daily for 2 to 8 weeks.
Which can be agonizing for someone who feels terribly ill when eating it. Once diagnosed, the only currently available medical treatment is a strict, lifelong gluten-free diet. And we have to emphasize, this is not a lifestyle fad for these individuals. It is an absolute medical necessity.
Absolutely. It means completely removing wheat, rye, barley, and their derivatives. Even tiny amounts of cross-contamination can trigger damage. International agencies say a product must have less than 20 parts per million of gluten to be labeled safe. That is a minuscule amount.
Managing this diet has a massive social and psychological impact. Eating away from home causes immense anxiety due to cross-contamination. People face social stigma, and navigating restaurants means constantly disclosing dietary restrictions. It can severely impact a person's relationship with food.
Not to mention the financial burden. Gluten-free foods are significantly more expensive. Furthermore, many gluten-free substitutes rely on starches from rice, corn, and potatoes, which lack the fiber and vitamins found in fortified wheat products, leading to potential nutritional deficiencies.
Even religious practices are impacted. The Catholic Church, for instance, requires that the communion wafer be made of wheat for a valid Eucharist. While low-gluten hosts are available, the Vatican still disapproves of entirely gluten-free bread for Holy Communion. That puts devout individuals with celiac disease in a very difficult position.
Similarly, during the Jewish festival of Passover, there's an obligation to eat matzah made from specific grains, which poses another major challenge, though many kosher for Passover products now use potato starch as a safe substitute. It is a daily obstacle course, and unfortunately, for about 20 to 40% of individuals, symptoms persist despite following the diet. This is called non-responsive celiac disease. Usually, it is due to unintentional gluten ingestion or a secondary issue like lactose intolerance or bacterial overgrowth.
But in about 1.5% of cases, it develops into refractory celiac disease, where the villus atrophy continues despite strict adherence for over a year. Refractory celiac disease is very serious and carries a high mortality rate. Type 2 is especially grim, as it involves abnormal T cells that increase the risk of a rare cancer called enteropathy-associated T-cell lymphoma.
Those serious complications are why early diagnosis and strict compliance are so vital. Thankfully, scientific research is pushing forward. We now have technologies like the NEMA sensor, which allows people to test a small sample of their food for gluten before they eat it.
There have also been clinical trials for new treatments. For instance, some researchers were previously looking into a peptide called larazotide acetate, which allegedly helps tighten the junctions between intestinal cells to stop gluten fragments from passing through the gut lining, although trials for it were discontinued in 2022.
They are also developing enzyme pills called glutenases, designed to break down and neutralize gluten right in the stomach before it can trigger an immune response. While these aren't cures, they could eventually act as a safety net against accidental cross-contamination.
It is truly a fascinating field of medicine that merges genetics, immunology, and daily dietary management. As awareness grows and diagnostic tools improve, hopefully we can reduce that estimated 70% of people who are currently undiagnosed and suffering in silence.
I completely agree. Education is the first step toward better health outcomes for everyone navigating this complex condition. Thank you to all our listeners for joining us on this deep dive.
We hope you learned something new today about the fascinating history and science of celiac disease. Take care of yourselves, and we will see you in the next episode. Goodbye.
This episode is based on the Wikipedia article Coeliac Disease, which is available under the Creative Commons Attribution Share-alike license. This podcast was crafted using artificial intelligence.